Energy and matter characterize both physical and biological systems. This means that energy and matter can change forms but cannot be created or destroyed. Energy and matter are often cycled within a system, and different forms of matter and energy are able to interact. The surrounding environment must be considered when studying a system's energy and matter. To examine flow into and out of the system. Scientists seek to study the flow and interactions of matter and energy, while engineers often seek to minimize inputs and maximize outputs of matter and energy relative to a given system. The Earth-ocean cycle began about 3.8 billion years ago when rain fell on a cooling Earth, forming the oceans. The rain came from the water vapor that escaped the magma in the Earth's molten core in the atmosphere. Energy from the sun helped power the cycle, and Earth's gravity kept water in the atmosphere from leaving the planet. The oceans hold about 97% of the water on Earth. About 1.7% of the Earth's water is stored in polar ice caps and glaciers. Rivers, lakes, and soil hold approximately 1.7%. A tiny fraction, just 0.001%, exists in the Earth's atmosphere as water vapor. When molecules of water vapor return to liquid or solid form, they create cloud droplets that can fall back to Earth as rain or snow, a process called condensation. Most precipitation lands in the oceans. Precipitation that falls onto land flows into rivers, streams, and lakes. Some of it seeps into the soil where it is held underground as groundwater. When warmed by the sun, water on the surface of oceans and freshwater bodies evaporates, forming a vapor. Water vapor rises into the atmosphere where it condenses, forming clouds. It then falls back to the ground as precipitation. Moisture can also enter the atmosphere directly from ice or snow. In a process called sublimation, solid water, such as ice or snow, can transform directly into water vapor without first becoming a liquid. On the other hand is the rock cycle. So there are three main types of rocks. First one is the sedimentary rocks. The second one is the igneous rock. And the last one is the metamorphic rock. Each of these rocks are formed by a physical changes such as melting, cooling, eroding, compacting, or deforming that are part of the rock cycle. Now, let's discuss about the types of rocks. Sedimentary rocks. Sedimentary rocks are formed from pieces. There are three different types of sedimentary rocks: clastic, organic or biological, and the chemical. When we say clastic, sedimentary rocks like sandstone formed from clasts or pieces of other rock. Organic sedimentary rocks like coal formed from hard biological materials like plants, shells, and the bones that are compressed into rock. The formation of the clastic and organic rocks begins with a weathering, or breaking down of the exposed rock into small fragments. Through the process of erosion, these fragments are removed from their source and transported by wind, water, ice, or biological activity to a new location. Once the sediment settles somewhere and enough of it collects, the lowest layers become compacted so tightly that they form solid rock. Chemical sedimentary rocks like limestone, halite, and flint form from chemical precipitation. A chemical precipitate is a chemical compound, for instance, calcium carbonate, salt, and silica, that forms when the solution it is dissolved in. Usually water evaporates and leaves the compound behind. This occurs as water travels through earth crust, weathering the rock and dissolving some of its mineral, transporting it elsewhere. These dissolved minerals are precipitated when the water evaporates. Let's now proceed into the metamorphic rocks. Metamorphic rocks are rocks that have been changed from their original form by immense heat or pressure. Metamorphic rocks have two classes: foliated and non-foliated. When a rock with flat or elongated minerals is put under immense pressure, the mineral line up in layers, creating foliation. Foliation is the aligning of elongated or platy minerals like hornblende or mica, perpendicular to the direction of pressure that is applied. An example of this transformation can be seen with granite and igneous rock. Granite contains long and platy minerals that are not initially aligned, but when enough pressure is added, those minerals shift to all points of the same direction while getting squeezed into a flat sheets. When granite undergoes this process, like at a tectonic plate boundary, it turns into genes or pronounced gneiss. Non-foliated rocks are formed the same way, but they do not contain the minerals that tend to line up under pressure and thus do not have the layered appearance of foliated rocks. Sedimentary rocks like bituminous coal, limestone, and sandstone, given enough heat and pressure, can turn into non-foliated metamorphic rocks like anthracite, coal, marble, and quartzite. Non-foliated rocks can also form by metamorphism, which happens when magma comes into contact with the surrounding rocks. The last one is the igneous rock. Igneous rock, derived from the Latin word for fire, are formed when the molten hot materials cools and solidifies. Igneous rock can also be made a couple of different ways. When they are formed inside of the earth, they are called intrusive or plutonic igneous rock. If they are formed outside or on top of Earth crust, they are called extrusive or volcanic rocks. Granites and diorite are examples of common intrusive rocks. They have a coarse texture with large mineral grains, indicating that they spent thousands or millions of years cooling down inside the earth, a time course that allowed large mineral crystals to grow. Alternatively, rocks that basalt and obsidian have very small grains and a relatively fine texture. This happens because when magma erupts into lava, it cools more quickly than it would if it stayed inside the earth.